Welcome to my presentation on proactive Citrix session anomaly detection using machine learning. In the next few minutes, I will introduce a machine learning solution to improve how IT teams monitor and support Citrix virtual environments. These systems are critical for enterprise productivity, but when sessions go wrong, like slow logons or high CPU usage, it often finds out too late. I like to change that by using machine learning to detect anomalies early and automatically. I'll guide you through the problem, the opportunity, to propose machine learning solutions and how to validate it, and at the end, how to deploy it into a production environment. Let's start with why this is a compelling opportunity for machine learning. In many IT environments, particularly with Citrix, performance issues are often invisible until users files a complaint. That delay hurts productivity and it can cost money or lives. This situation fits all three criteria from module one for an ideal machine learning use case. First, there's high uncertainty. That's a reality. We cannot predict exactly when or where an issue will occur. And the second one is it's the data rich. We have a lot of information. Tools like a Uber agent and Splunk collects hundreds of telemetry. This point of data across all of the thousand of sessions every day gives you all the information that you need to start training all these machine learning products. And finally, it's highly actionable. If we can detect anomalies early, IT can take a, let's say, the action before users are even aware there's a problem, or at least stop a little bit a bigger impact into your production environment. Um, what we have is from the Chris DM perspective, the objective is clear. We need to reduce support load and downtime by being proactive. We need to identify performance problems. Our success will be measured using both output and outcome metrics. From the output standpoint, we include model level measures like precision and recall. Um, what we want to take a look here is use the model to detect real issues while avoiding false positives. The outcome metrics are business focused. We need to reduce the volume of tickets, of calls to the help desk team. This is going to reduce the time resolution of issues. Usually, it helps about 40 to 60%. I've seen uh, some situations that it's also bigger. And also, we need to improve the user satisfaction. Um, Having a happy user with good user experience, that's the goal on an enterprise level. These features will use or that we're going to be using come from the session from the Citrix session logs, and we are going to monitor resource usage like logon times, uh, application crash frequency, high resource utilization like CPU, memory, uh, IOPS, and network utilization. So all of this is going to be collected through an agent installed on the endpoint device, and that's where we're going to start modeling our machine learning project. Um, Once we have all this for validation, we're going to use the interactive process. First, we'll build let's say, a baseline model using a supervised learning algorithm like a random forest. Um, this is going to be trained on historical data about session logs and that are normal and anomalies. What I mean, in other words, uh, having two type of sessions. Sometimes some sessions that looks good with good resource utilization, and the other ones that are out of our thresholds and there's an anomaly there. Then we'll refine it with feature engineering, including the user-specific behavior patterns and time series trends. The third part that we're going to be using is to deploy the model in a real environment. We want to use a test environment first, a development environment, just to make sure that we are gathering all the all the data, and then we're going to be moving forward to production. But the goal here is to monitor how well it flags new anomalies. And finally, uh, we'll build a feedback loop with IT administrators to confirm if all those anomalies are valid or are false positives. That input from the IT administrators is going to help to improve the model and retrain it over and over again with a higher quality labels. So interaction with IT administrators, it's a key for the success of this project. Um, Now let's talk about a little bit of the design and what's next. Um, let's use a cloud-based infrastructure. Um, the tools that we're going to be using are Splunk and Uber Agent, and they are already built to collect that type of session data. So we are going to be centralizing all on those places. This is going to make our model deployment and monitoring solution really easy. It's something that it's already there. We just need to utilize the data that they collect, and we're going to build our machine learning product. We're going to be using offline learning with the scheduled retraining. Probably we can start with weekly or monthly. It depends on the data granularity that we want for our model. Uh, for inference, we'll use online predictions. We're going to be using a score incoming session data in real time. By default, Uber Agent gathers metrics every 30 seconds. We can, and it sends it over to Splunk. So we can have a big volume of metrics and it consumes a lot of storage on the Splunk side. So we can play with if we need real metrics every 30 seconds or we can make it every 5 minutes. It won't have a big difference in terms of an anomaly if a CPU or memory spikes its utilization by 5 minutes. And a last but not least, uh, let's think about moving into production. We we train our model. We had information from or feedback from the IT administrators. So what's next? There are several risks we need to consider. What is and the first one I consider is training services, and that is going to give us a little bit more of information, but we can mitigate all these failures or issues by aligning the feature pipelines and testing them every single day. Another risk is the data or concept drift. User behavior and application change, especially with seasonal patterns or software updates. So not always we have the same users or the same number of users. So that is going to have or give us a little bit of a deviation on the numbers or the resource utilization per server.